Hi guys, welcome back to my channel. Today I'm going to teach you that's a continuation of the ionic bonding. Hopefully I'm going to finish that ionic bonding in this video. And one more thing, it's good that you're here to watch my channel. I know my channel is growing bit by bit and I love to see your support, guys. Thanks. You know, the summer vacation is coming up and my suggestion is that those who have done your GCSE examination, I really appreciate your effort, those who have done your GCSE and put your hard work to write your GCSE examination. And one more thing, you can utilize that time in summer by watching my videos. It will be a good boost up to fill the gaps between the GCSE and A level. We think that the A level will be easy. It will not be easy and the piece of cake. There will be a big gap or there will be a big jump between the GCSE and A level. So please, it is my suggestion or recommendation. During your summer break, at least per week or every alternate days, you can watch my videos to boost your grade or to catch up with your teacher when your teacher will start actual lesson. Okay then? Yeah. Now, today I'm going to teach the properties of the ionic compound. Yeah, now let's start. Properties of the ionic compound. We have already done the formation of the ionic bond and the conditions for the formation of the ionic bond. And in my last video, I realized I made a small mistake. I gave a homework to my student about for the drawing of dot and cross structure of which one is that, of aluminium draw dot and cross structure of draw dot and cross structure of aluminium nitride. Accidentally I wrote the formula of Al3N2. That's wrong, guys. That's wrong. Aluminium is 3 plus, Al3 plus, and nitrogen is 3 minus. So plus 3 minus 3 cancel. The formula is Aln, like Alan. Okay. Now, can you try about the dot and cross structure of aluminium nitride? Okay. Aluminium will give away 3 electron and nitrogen will gain 3 electron. That's why it is Aln. Aluminium is from period 3, group 3. So it gives away 3 electron. Group 3. So 1 aluminium is enough. Al. I don't know what happened to my markers. Al 3 electron in the outer shell. Nitrogen has 5 in the outer shell and gain 3 to complete its octet configuration. Nitrogen 1, 2, 3, 4, 5. Gain from the aluminium, gain from the aluminium, and gain from the aluminium. So aluminium become Al3 plus, and the nitrogen become N3 minus, N1 dot and cross, dot and cross, dot and cross. 1, 2, 3, 4, 5, 6, 7, 8. 3 minus. So it is Aln. Now the chemical properties of ionic compound. Okay, look at that. Can I rub the both? Is that okay? Okay. Now, aluminium nitride. Now, ionic chemical properties of ionic compound. They all are solid. We know that they are solid. So they have chemical properties of ionic compounds. Chemical properties. Physical mostly. Chemical is same because they lost one electron and someone gained one electron. Physical. We will start the physical property. Physical properties of an ionic compounds. Guys, they are solid in state. So first, they have high melting and boiling point. First thing, they have high melting and boiling point. Any idea why they have high melting and boiling point? You know, the force of attraction between the two oppositely charged ion will form ionic bond. So it is a type of electrostatic attraction, very strong attraction. So when they join, they form a solid compound. Like for example, NaCl, Na plus Cl minus. They come together and form a solid sodium chloride. There exists an electrostatic force of attraction between these two ions, so it's hard to break them, or we need more energy to separate them into ions to break them. That's why they have a high melting and a boiling point. They exist in the solid form. That's why this force of attraction creates a strong bond. So all the ionic compound need more energy to break them apart. Now, next thing, they are soluble in polar solvent. Underline the word polar. I will teach you what is meant by the term polar or polarity, non-polar, polar solvent, when I will teach or when I will discuss covalent bonding. Polar covalent compound, best example is water. So they all are soluble in water and insoluble in non-polar solvents and insoluble in non-polar solvent. Can you give me the example of a non-polar solvent, guys? Benzene, carbon tetrachloride, non-polar solvent. Okay, propanone, non-polar solvent. So all the ionic compound easily dissolve in polar solvent, like water. They dissolve in water. Now, can they conduct electricity? Yes, they can conduct electricity, but we have a condition for the ionic compound to conduct the electricity. Okay, not last, they are good conductor of electricity. When they are the good conductor of electricity? Only in molten form and in aqueous condition. Only in molten state. Molten state, it's just like a paste. Like when you heat the solid cannot directly convert into vapor form. That's called sublimation. It forms a paste like jelly like state. This state also conduct electricity. and obviously aqueous solution, their aqueous solution. When you dissolve all the ionic compound in water and make its aqueous solution, this aqueous solution is the good conductor of electricity. Okay, you can ask one question, sir, why the ionic compound in the solid form cannot conduct electricity? Yes. Before that, I will give you one question, then I will discuss why they can't conduct electricity in the solid form. Okay, write down one question. This is a past paper question from the OCR, A-level past paper question from the OCR. Okay. Explain solid sodium oxide is a non-conducting electricity, whereas liquid does. What's your answer, guys? Why the sodium oxide in this solid form cannot conduct electricity? What's the formula, first of all? Can you write the chemical formula of sodium oxide? Yes, easy. I showed you the technique how to write the chemical formula of sodium oxide. Na, give away 1 electron, oxygen can 2 electron, so crisscross only numbers, only this numeric number, not the charges, Na2O. So in the solid form, it cannot conduct electricity. Why? What's the reason? Some of the students said that, sir, due to the absence of delocalized electron. Don't use the term delocalized electron. Ionic bond is not because of electron. Ionic bond is because of the formation of the ions. In case of the solid sodium oxide, there is no free ions. Just answer should be short and sweet. So what's the answer? I've seen the mark scheme. So what's the answer? No free ions. So in solid sodium oxide, there's no free ions. All the ions are compact, so there will be no movement of ions. Solid sodium oxide do not conduct electricity because there is no free ions. Yes. Okay. Now we will compare solid NaCl, molten NaCl, and aqueous NaCl, which will conduct more electricity or no electricity. See that. Solid NaCl, liquid NaCl, and molten NaCl. Now, what do you think? NaCl, NaCl, NaCl. Solid, molten, and last one is liquid or aqueous. Which state will conduct more electricity? Obviously, no, it will not conduct electricity. Reason? No free ions. Yes, yes. Among these two, what do you think? Which one will conduct more electricity? I will teach you electrolysis. Electrolysis is a GCSE topic. So when we do the electrolysis, when we write down in terms of electrolysis, more ions are produced in case of aqueous solution, and less ions are produced in case of molten state. All these ions, they move to the respective electrode, like anode and cathode. I will make a separate video on electrolysis topic. That's the GCSE topic, but I will make it separate topic for the video on that topic. So this one has less iron, no doubt. Free ions, 100% free ions. Less free ions, more free ions, more free ions. Some of my smart students were asking the question, sir, which one conduct more electricity? Obviously this one, because it has more free ions. So when it will be asked in the examination why the ionic compound, either in the molten state or in the aqueous solution, conduct the electricity, what's the answer, guys? The answer is there will be free ions. Don't write delocalized electron. Delocalized electron for metallic bond. We will come to the metallic bond at the end of we will come to the metallic bond. Next, I'm going to start covalent bonding, then the dative covalent bonding, then the metallic bonding. Okay, one more question. Before I am going to wind up my lesson, one more question based on the chemical properties of ionic compound. One more question. Look at that question. You know, they have high melting point and a boiling point. I will give you 3 ionic compounds and you have to let me know which one has more melting point. NaCl, which one of the following ionic compounds have more, which one of the following compound has more melting point? NaCl, MgCl2, A NaCl, B MgCl2, C AlCl3. So chlorine is same. Ignore the chlorine. Now Na has Na plus charge, Mg2 plus, Al3 plus. The more the magnitude of the charge, make the ion more smaller. So like we have done one equation, force of attraction, Q1 Q2 by R square. This we use when there will be a force of attraction between the oppositely charged ion. Look, you have to check which ion has more magnitude of the charges. Chlorine is Cl minus, Cl minus, Cl minus, Cl minus. So Al has more magnitude, so it has more strong force of attraction. Which type of attraction? Electrostatic attraction. More electrostatic force of attraction mean more percentage of ionic character. More percentage of ionic character mean it need more energy to break this AlCl3 bond. So AlCl3, aluminum trichloride, has more melting point. Okay guys, thanks for watching this video. I will come back soon with one more video. In that video, I'm going to start covalent bonding. Thank you. Bye.